Okay, so this last part, there's a lot to this, and this is the newest stuff. So this is kind of the hardest stuff. And so I want you to pay attention closely to this, and I'm going to explain a couple of different things. The different parts. And I'm just going to start with explaining this. Let me get a separate piece of paper for this. If you don't have this written down somewhere, you need to have this written down at this point because this is how you graph these things. You have x, you have y. You have sine and cosine. X, comma, y. Okay? And so what we're going to do is we are going to figure this out. Now, when it comes to sine and cosine, we don't use normal x's. We don't use 1, 2, 3, so on and so forth. We use what's known as radians. And the radians we use, remember, are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And for sine, and we're going to do the same x values for sine and cosine. And remember, the pi's honestly are an afterthought. Technically, this is, and remember, we have our little cheat sheet that tells us something like this, is that we know that 0 is the same thing as saying 0 times pi, okay? Pi over 2 is the same thing as saying 1/2 times pi. Pi is the same thing as saying 1 times pi. What is it? 3 pi over 2 is the same thing as saying 3 over 2 times pi. And then 2 pi is the same thing as saying 2 times pi. Pi over 4 is the same thing as saying 1/4 times pi. And like pi over 8, whatever it is, it's really just a fraction or a whole number times pi. And honestly, you can think of it like that so that when you actually get to the multiplication, adding, and subtracting parts, it's not as hard. So I'm going to look up at this first one. We have all of this stuff, right? And since we have all of this stuff, we know that the y's on a sine value go like so. They always go 0, -1, 0, 1. I'm sorry, it's backwards. Should be 0, 1, 0, -1, 0. And that's how that works. On a cosine, you start off with the 1, you go to 0, you go to -1, 0, and then you go to 1. Okay, so that's what that should be right there. And so it's these basic stuff that we need to use on each of these problems. The last thing that we need to know about is how things affect everything. So let's say I had 3 cosine of theta minus pi. Let's say we have that. Okay. Anything that's in this spot only affects the x values. Anything in this spot only affects the y values. Okay? Only affects the y values, only affects the x values, okay? So you only, when you're looking at this, you're only doing something to one or the other, or maybe even both, but you only do it for the part that it's suggesting you to do it for. So for example, let's look at this very first problem. I'm going to do a couple of these because these are a little hard, but I'm going to show you this first problem. So we know that this is going to be sine of theta, or 3 sine of theta minus pi. So first you need to know that we're always doing the opposite of whatever's here. So in this case we're adding, so the opposite of adding is, the opposite, right here we're subtracting, the opposite of subtracting is to add. And so we're going to do this. We're going to make an x value where we add x plus pi. Alright? we're going to do x plus pi in this case. So the first x value on sine is 0. 0 times pi plus, what is pi? Well, it's 1 times pi. And we're only going to add these numbers out here. We're going to take 0 plus 1, and that's going to give me 1. And that's going to be 1 pi, so we're just going to put pi right there. The next thing is 1/2 times pi plus 1 times pi. So 1/2 plus 1, if you put in your calculator, you'll get 1.5. You turn that into a fraction, you'll get 3 over 2, or 3 pi over 2. Okay? And then you do 1 times pi plus 1 times pi, and that's going to give you 2 pi. And you keep going down the line. And that will give you 5 pi over 2. And then 2 times pi plus 1 pi equals 3 pi. Alright? And so what we're going to do now is we're actually going to we're going to try to graph these. But first we need to figure out our y's. Now, whenever you have a number in front of sine, that technically changes the amplitude. And the amplitude is just the y values. And the y values are always being multiplied. In this case, we're going to multiply all the y's by 3. Okay, so the first y value in this was 0. 0 times 3 gives me 0. Then it was 1 times 3 gives me 3. This would give me 0 times 3, which gives me 0. Negative 1 times 3, which gives me negative 3. And then finally 0 times 3 again, which gives me 0. And so I can actually graph these on this chart right here. I can first find pi, and then go up 0. So pi is right here, and then I'm just going to put big dot right there on 0. Okay? Then I'm going to go 3 pi over 2, and then I'm going to go to 3. So here's 3 pi over 2. I'm going to go up to 1, 2, 3, and put a big dot up there. I'm going to do the next one, which is 2 pi, and that's going to be 0. 5 pi over 2 will be negative 3. And then 3 pi will be 0. So what you did was you actually made the amplitude bigger, and the normal graph starts over here, and so you shifted this to the right an entire pi. Okay, so you shifted it to the right by pi. And so that's what it's going to look like when you are adding / subtracting. Alright? So I'm going to flip this from adding to subtracting, because these are all the same. If you're adding, if you're subtracting, you're actually adding that thing. If you're adding, you're actually subtracting, so on and so forth. Now, if I flip over to something like, let's say we look at this. All right. This has two things. It is now doing something to the theta itself, and it's adding. Okay, so this means that we have to actually do two things. First, because it's dividing by 2, we have to take x and we have to multiply it by 2. Alright? And since it's adding pi, then we're going to subtract pi. And that's what we're going to do right here. So we're going to start with the same thing. So it'll be 0 times 2 minus 1, essentially. So this is actually 1. So 0 times 2 minus 1 will still give me negative 1, which will be turned into negative pi. The next one is pi over 2, which is the same thing as saying 1/2. Take 1/2 times 2 minus 1. 1/2 times 2 is 1. 1 minus 1 gives me 0. So it's going to be 0. And then it's going to be 1. 1 times 2 is 2. Minus 1 gives me 1, so that'll be pi. Then I will do 3 pi over 2, or just 3/2 times 2, which is 3, minus 1, which is 2. 2 pi. And then we'll do 2 times 2, which is 2 pi, times 2, which is 4, minus 1, which is 3 pi. Okay? And what you'll notice is there's no number in front, so the y's actually stay the same. So this would be 0, 1, negative, 0, negative 1, 0. Alright? So we're going to start here. we're going to put that dot there. We're going to go to 0, 1, we're going to put that dot there. We're going to go to, 0, 1. 0, 1 will be right here. And then we're going to go to pi, we're going to put it right there. Then we're going to go to 2 pi, go to negative 1. We're going to go to 3 pi, and we're going to put it at 0. So what your graph does is it actually expands out, so it stretches out, and it's shifted to the left 1 whole pi unit. All right? So that's how you do the adding, subtracting, and that's how you do the multiplication. The next thing is the trig word problem. Now, I didn't really put the regular trig problems on here for a reason. The reason is that, like, honestly, you just need to be able to really solve all that stuff on here with the word problems. And so I'm going to do about I'm only going to do like 1 or 2 of these just to show you what's going on. So let's do this first one. Now, since we're dealing with regular trig problems, you actually have to start out by making a right triangle, all right? Because we know that's what's going to happen. So it says over 2 miles horizontal. So there's only one of these 3 lines that's actually a horizontal line. I know that this is a horizontal line, so I'm going to put 2 right there. A road rises 300 feet, okay, vertically. So this is 300 right here. What is the angle of elevation? Now, here's the problem. We have feet and we have miles, okay? Problem with that is that we need to convert one into the other. Now, I know that miles, and I don't expect you guys to, but I will let you guys know. Miles actually is 5,280 per mile. So I'm going to take that, multiply it by 2. That's going to give me 10,560, okay? So that's going to help me out in the long run. What it's trying to do is ask me what's the angle of elevation from here. So what I have to do is figure out what my 2 sides are. First, what is this 300 right here? Well, I know the 300 is my opposite side. Why? Because it's opposite the angle. I know this is the hypotenuse, even though it doesn't really care, but this is the hypotenuse because it is across from the right angle. And lastly, this is the adjacent side. So I had to figure out which one of my 3 trig functions, tangent, sine, or cosine, has opposite over adjacent. Well, I know tangent is opposite over adjacent. So I know that tangent of some angle equals 300 over 10,560. Okay? I know that. My next step is try to figure out what the angle is. So first, let me figure out what 300 divided by, what is it, 10,560? That gives me 0.0284. 0.0284. All right? So now I know that the tangent of x equals this number. So in order to find what this x is, I actually have to do the inverse of x, which is tangent negative 1. And I have to put this little decimal inside of it. Now this trick is going to help me later when we get to the law of sines, but right now I just want to do this. So we do second, we press the second button, we press tangent. Okay? And we're going to put in that decimal, 0.0284, close the parentheses, press enter. Okay? What that tells me is that we're going up at an angle of 1.6 degrees. It's a very slight angle. Okay? Now, I'm going to skip the second one because that one is actually like the first one in which you're trying to find an angle. Now the second one I'm going to try to do because it actually has an angle. It says a blank, apparently I didn't want to put anything there. A is trying to figure out how tall his house is. I'm assuming that's supposed to be a man. He knows the ladder he uses to reach the top is 17 feet long, and the angle of elevation he needs to reach the top is 46 degrees. What is the height of the house? So 1, I know I'm going to draw this triangle. I got to figure out some stuff. First, which one of these three sides is going to be the house? Well, I know this is the house because houses don't lie on the ground and they don't line diagonally. The only architecture that lines diagonally is the Leaning Tower of Pisa, and we're not talking about that. So we have X right here. The next thing we need to know is we need to know which one's the ladder. Well, ladders, once again, you can't reach the top of a roof if it's on the ground, so this would have to be 17 right here. And lastly, is we need to know that the angle of elevation is 46. If you have an angle of elevation or an angle of depression, you always want to put it right here because they're the same thing. So we're going to put 46 right there. Our next step is to figure out, all right, what two sides do I have? Well, I have this x, and I know it's opposite of this angle, so I know that's opposite. I have this 17, I know that's the hypotenuse, so I'm going to call that the hypotenuse. So I know that this is sine. Okay, so I know that the sine of an angle, which in this case is 46, equals the opposite over the hypotenuse, which is 17. Okay? So what I'm going to do here is I'm going to try to get x by itself. Alright? If x was on the bottom, this would be a little bit harder, but since it's on the top, this is actually pretty easy. First, we need to get whatever's on the bottom, it doesn't matter what it is, letter or whatever, out from under the fraction. So we're going to multiply by 17. So we get 17 times the sine of 46 degrees equals x. Alright, now we have to determine, is x by itself? If it is, we don't have to do anything else. If not, we'd have to divide. Well, x is by itself. So all I gotta do is type in my calculator, 17 sine of 46, close my parentheses, and I get 12.2. So that means that the house is 12.2 feet tall. Okay? Alright, now on to the next thing. Law of sines. Now, these are not as hard as we as some people try to make it out to seem. This is actually just setting up ratios. Sine of an angle over its opposite side. Sine of another angle over its opposite side equals the sine of another angle over its opposite side. All of this is stating is that if you take an angle and its opposite side, if you take the sine of an angle divided by its opposite side, it comes out as the same ratio as you would anything else, okay? So I'm going to do two of these. One where you have to figure out an angle, and one where you have to figure out a side. So first I'm going to do the side. I'm going to determine one thing and one thing only. Do I have a side, do I have two sides, or actually first, do I have a side and an angle that I know? So first, 45, I know that angle, I don't know this side. 35, I know that angle, I don't know this side. I don't know this angle, but I do know this side. So this is the dilemma. We need to make a ratio where we know both the angle and the side. But the thing is we're in luck in this case because we know what triangle angles should add up to be. We know that all three angles should equal 180. And if you already know two of these angles, the third one's pretty easy to find. You just need to take 180 minus 45 minus 35 to get the third angle. That gives me 100, right? Now I know an angle and I know its opposite side, okay? It doesn't matter which one you label as which, but just label one A, B, C. Doesn't really matter. But what does matter is to know that the opposite angle is the smaller version of that. So the smaller letter. So right now I know what is this? Big B is 7. So that means that little b has to be 100. I know that I'm trying to find big A, which is x, so that means that I need to include its angle, which is 45. I do not care about big C or little c in this case, just because we're working out a ratio. So from here what I need to do is I need to actually set up my ratio. I need to do sine of the small letter. So sine, in this case, we're going to do 45 over its bigger letter, which is x. Sine of the smaller letter, 100, over its bigger letter, which is 7. From here, we need to cross multiply. So that means the 7 multiplies this, or I'm just going to put 7 sine of 45. And then x is going to multiply this, which will be x sine of 100. What we have to do now is actually get x by itself. So in order to do that, we need to get rid of the sine of 100. Sine of 100 is an actual number, and a lot of people don't think of it like that because they see SI and they're like, oh, those are letters, that's not a number. No, this whole thing is the thing we have to divide by because this is actually a number. Sine of 100. What we do to one side, we do to another side. That leaves me with 7 sine of 45 over the sine of 100 equals x. So if I plug that in my calculator, 7 sine 45 close parenthesis divided by sine of 100 gives me the answer of 5. So round to the nearest whole number, so know that x equals 5. And so that would be my answer for the missing side. Now, sometimes you're going to get missing angles. So here is a missing angle. In this case, if you have a missing angle, you're going to need to have the ratio already set up. So the 60 and the 19 are already good. This x and this 15 is what we're going to try to find. We're going to try to figure out what this x is. So once again, label the sides. It doesn't really matter which one's which. I'm just going to label A, B, and C. Okay? So, I know big A equals 19. I know little a, which is its angle counterpart, is 60 degrees. Alright? I know big B equals 15. I know little b is x. So once again, I'm going to set up my ratio. Sine of the little letter, let's say x, over the big letter, which is 15. Sine of the little letter, which is 60, over its big letter, which is 19. We're going to cross multiply. 19 times sine of x equals 15 times sine of 60. Okay? So now that we have that, what we're going to do is we're actually going to try to get x by itself. But because x belongs to sine of x, we're just trying to get sine of x by itself for right now. So first I'm going to get rid of 19. That gives me sine of x equals, I'm going to put this in my calculator, 15 times sine of 60 divided by 19. 15 sine of 60 divided by 19. And that gives me 0.684, I'm going to say. All right? 0.684. And now since we're trying to find this x, and we have the sine of x, and we're trying to find an angle, remember from the previous thing, you're going to use the inverse. So we have to use the sine inverse to figure out what this number is. Okay? So I'm going to use the sine inverse, so remember you press second, and then you press sine of 0.684. And we figure out that the angle is about 43 degrees. So I'm going to put 43 degrees, and we're going to call it a day. All right? Ooh, all right. Next thing is law of cosines. So the law of cosines is actually pretty much the same thing all the way throughout. Is that when you're trying to find a side, all right, so I'm just going to call it C. Just make everything big C, just for yourself. Okay, so C squared equals A squared plus B squared minus 2 times big A times big B times cosine of C. So So I'm just going to tell you guys, like, honestly, I could change this up. I could start putting a squared and things would change up. But honestly, it's easiest to just do this. Let's just call this big C. All right? Wherever you see the X, whatever side you're trying to find, we'll call big C. We'll call the other two big A, big B, doesn't matter which. Okay? And the reason why we have the law of cosines is because this cannot be solved with the law of sines. And because this cannot be solved with the law of sines, we need a second thing to be able to figure that out. So this is what we're going to do. We know that c squared, meaning this x, equals a squared plus b squared. So I've got 15 squared plus 9 squared. I subtract 2 times 15 times 19, or 9, sorry, and multiply by the cosine of the angle, in this case is 62 degrees. Alright? So what I'm going to do is I'm going to figure out, okay, so this is 225 plus 81. I'm going to subtract 2 times 15 times 9 times cosine of 62. Alright? This is pretty basic. You just put in your calculator. Okay, so I'm just going to put in 225 plus 81 minus 2 times 9 times, times 15 times 9 times the cosine of 62 degrees. And that's going to give me 179.2. Okay. So I know that c squared equals 179.2. Now I'm not over, it's not done yet. We still need to get c by itself. So in order to do that, I actually have to square root both sides of the equation. So if I take the square root, 179.2, I get my answer, which is about 13. So I'm just going to put 13.4 and call it a day. All the rest of these, you do the same exact thing. Alright? Same exact thing. Just always label the XC, and then you can do the same exact thing. Alright? Last but not least is the law of sines and cosine word problems. I'm going to do one for the law of sines and one for the law of cosines. Just to show you what, like, honestly, I'm not going to solve them. All I'm going to do is I'm just going to show you how to figure them out. Because honestly, that's the hardest part, and then you guys can solve them from there. So it says a spaceship. Alright, so this is what I always want you guys to do. Draw all the things that it tells you. It says spaceship. Mine's going to look like a little fish. It's a spaceship. Well, there's little things coming out of it. It's a little spaceship. Sees two planets in the distance. Alright, here's planet A. There's planet B. Okay. It knows that the length to the first planet is 200 light years. So I know this is 200 light years right here. Second planet is 250 light years. So this is 250 light years. If the angle from the ship to the two planets is 55 degrees, so I know this is 55 degrees, how far are the two planets? So it's asking you how far these two planets are, x. Alright? I can tell you right now that you see two things with an angle in between. You know you're going to use the law of cosines for this one. Alright? Honestly, the hardest part is really making this picture and figuring out what you're doing. And then like getting to the law of cosine, law of sines. As long as you understand how to do those, then it just becomes pretty easy. The hardest people always think, oh, this is so hard because it's a word problem. Actually, it's not. You just need to draw pictures. Try to figure out what it's trying to tell you to do. For example, on the second one, let's just draw this out. Angel and Shakira go on a hike. Alright, so we have Angel, we have Shakira, they're on a hike. They're spaced about 20 feet from each other. So we know this is 20 feet between them. And they see a bear. Alright, you got a little grizzly bear, a little guy over here. Alright, it's the crappiest drawing in the world, I don't care. Alright, so that they know Shakira knows her angle to the bear is 53 degrees. That means that if we draw from Shakira to the bear is 53 degrees. And Angel knows her angle to the bear is 45 degrees. How far is the bear from both girls? Okay. So this is what you're going to do first. Alright, I'm just going to explain what you're supposed to do for this. So first you're going to find this third angle. Remember, it's 180 minus these two things. In this case, it will be 82 degrees. Yes. 82 degrees, okay? So you know that's 82 degrees. So what you're going to do is you're going to set up your ratio. This is the law of sines. You're first going to set up your ratio for this one to figure out this side, and then you're going to set up the ratio to figure out this side. You're going to have to do this twice, but it's not going to be that hard to do. Trust me. You've got this. It's pretty easy once you understand what the law of sines is. All right? Honestly, I'm going to do this really quickly just to show you the answers, just in case you're trying to figure that out, but that's all I'm going to do, all right? So I'm just going to set these up. We know that I'm just going to call this side A, this side B, this side C. All right, so I know big C is 20. I know little c is 82 degrees. I know big B is X. Little b is 45 degrees. Big A is also X, and little a is 53 degrees. Okay? So first you would set up the one for Angel, all right? You would do sine of 82 over 20, because this is the only complete ratio we have is C, so you need to use C to compare that, all right? Then we're going to do the sine of 45 over X. You cross multiply like normal, and then you'd solve. Same thing with, the only thing that would change for Shakira is that this would be 53 instead of 45. You'd solve it the same way. You cross multiply and then solve. Okay? So those should be all the problems. If you have any questions, always ask me. That's why I have 3 days for the final, is just so that you can ask me questions in between days, not during the test, but in between class, if you really need the extra help. I want you guys to know this. I'm not, I'd rather you guys know it than like know it right away. If you guys